In the previous two sessions, we saw how we connected to a Raspberry Pi simulator, collected the streaming data, and pushed it to the data lake, and then visualized the data on a Power BI desktop application. However, this data is a static data. That means you can visualize last 1 month's data, last 2 months' data like that. We now want to visualize the live data. As and when the data is coming, I want to, let's say, see a graph, how the temperature is moving, or I want to see a dial, how the temperature is moving. For this, we have to connect the streaming data directly into the Power BI. Now we can connect it to the Power BI desktop application. However, that's slightly complex from a configuration perspective. So for the purpose of this particular video, what we're going to do is we're going to log in to the web version of Power BI, and that can be easily connected to the streaming data. Now, what you need to do is you need to open a tab in the same browser where you are having the Azure open. And in that, you have to sign in to app.powerbi.com, is a web version of Power BI with the same ID as you are using for your Azure. So both these IDs have to be the same in order for them to talk to each other and push the data live into Power BI. So we will log on to Power BI with the same ID. Since I have logged in to Power BI before, I will appear already logged in. By the way, some of you might be knowing that Power BI is getting deprecated and it will be replaced by Microsoft Fabric. But as of now, we will be using Power BI. So you can see here the Power BI, we have logged in with the same ID as we have over here. These two IDs have to be the same. And the next thing that you will see is that we have my workspace. So there's only one workspace, which is my workspace. Now, in the free version of Power BI, you cannot create more than one workspace. So we have to use the default workspace here, okay, which is fine as of now. But in industry, of course, you are going to use a paid version of Power BI and Power BI, desktop application or a server-based application. And in that case, you can create multiple workspaces. The next thing that we are going to go do is we'll go to this elements that we have created. So last time we created an IoT hub, we created a data lake, and we used stream analytics job to push the data into a data lake. But this time, instead of pushing the data into a data lake, we'll push the data directly to Power BI. So in the stream analytics job, the first thing that we have to do is to make a new output, which will take the data to the Power BI application instead of the data lake. How do we do that? We will just create a new output. Right now we had this one in sensor. So this was going into the data lake, but now we are going to create a new output, and this output will go to a Power BI. Let's call this Power BI. And the workspace is my workspace. So it has already taken this my workspace from here because it recognizes that it is logged in the same device. And we will use the user token authentication. Now, in the Power BI workspace, I want to create a data set. And within a data set, I want to create a database which will contain the data from these the sensors. And this data set has to be updated in real time. And from there, we are going to build the dashboard. So we will give a name to the data set. Let's call this name sensor data. We give today's date just to differentiate from any other data, sensor data that is available. And for convenience, we are giving the same name as, of the data set and the table. We're keeping the same name for the table as well as the data set, but you can use a different name as well. And we will authorize this. Moment you authorize this, what is going to happen is that it is going to ask you for access to this Power BI. Okay, but remember that this works only when the Power BI app and Azure are open in the same tab, are open in the same browser but in different tabs. We'll just authorize. It's asking me to sign in, so I have to sign in with the same ID. So let me just sign in. So once you have successfully signed in, this authorize will become gray. This means that it has successfully authorized. If it becomes red or it gives an error, that means it has failed to authorize. It is telling me that this will be decrypted in 2027. We have some time, but after 2027, we have to move to Fabric. We are yet to see how Fabric is going to look like. Okay. So as of now, we'll continue with Power BI. We'll save this. It's adding the output and it's testing the output, whether the output is okay or not. So the connection seems to be okay. And now we have this Power BI output. The connection is successful. Now the query needs to be rewritten this time. Why it needs to be rewritten? First of all, of course, the output now is different. So the output is no longer sensor output. Output is you can just type it. You can see the connection symbol over here, which indicates that it has been successfully connected. Now, there's another reason why we need to change this query. Now, let us understand this from a conceptual perspective, what changes we need to make to the query. We want the live streaming data to be visualized in Power BI. However, there's a slight problem. The challenge is that the response of Power BI, which is a visualization tool, may be not in sync with the speed at which the data is coming. And we need uniform flow of data to be visualized in Power BI. So imagine this, that you have the data coming in streaming format. And previously this was going into a data lake, but now this needs to be visualized in Power BI. So what Power BI needs is a consistent flow of data and not that fast, so that it can catch up with the latency. So essentially what we'll do, we'll break up this data into small time slots. These time slots are also very small, so it is near real time, but probably not fully real time. And what we are going to do, we are going to make an average of, let's say, temperature or humidity for this window of time, and we are going to flow this average into Power BI. So our query will essentially change to calculate this average of temperature and humidity and flow that into Power BI rather than taking the temperature and humidity directly and flowing it into Power BI. So to that extent, we have to slightly alter our query. So let us write the query and then understand what this query is doing. You can see that I've altered the query saying that you select a timestamp and the timestamp should be the end of the window. So we say that we are going to average the temperature and humidity that we receive within a window of time. But then when you are displaying it in the Power BI charts, we have to give one time, and that will be the end of the window time. And during that window, we are going to average the temperature and the humidity. We'll take the data from the IoT Hub and put it into the Power BI output. And we are going to average it by grouping into the tumbling window, which is of 2 seconds. So the window will tumble every 2 seconds, capture all the temperature and humidity that is there, average it out, and push it to Power BI, and Power BI will visualize it. So essentially, we are aggregating the data every 2 seconds. So our real time is not fully real time, it is near real time. It can show you the average temperature over a period of 2 seconds, which in most cases should be good enough. We are not doing it fully real time because Power BI as a visualization tool may not be able to catch up with the fast speed at which the temperature or humidity data is coming. And we may not need it to that extent. Okay. So that's the change that we have done. We'll test the query. And once we test the query, what it's giving is that it is giving you one record, which is basically an average of all the records that we have got so far. So this means that it is able to run the average function. We'll save this query. And just like last time, we are now going to start the job. But this time, we are going to push the data into Power BI real time. We'll start the job. Just like last time, it will take a little bit time to start the job. We'll start the job and we'll start afresh. We'll not continue with the previous job. It will take a little bit of time to start the job. In the meantime, you can keep refreshing and checking whether the status has changed from starting to running. We'll be back after the job starts running. The job has started running now. We will now start the Raspberry Pi. So Raspberry Pi has started and it is started to collect the data. Just wait for maybe 30 seconds for some of the data to get accumulated. And once that is done, you'll see a very interesting thing. Remember, now the data is not going to the data lake. We are pushing directly into the Power BI. Go to the Power BI tab. go to my workspace, and you will see a very interesting thing that you see this new data set has got created. You can understand this because this is the name of the data set that we created. That means it has pushed the data and created a database, and hopefully it has also created a table which is getting updated on real time as more and more data is getting pushed. Now, what we want is uh, we want to develop certain charts on this. How do we do this? Let's go to new item. And in the new item, we have this dashboard. We like to create some real-time dashboard with the streaming data that is flowing in. We'll give a dashboard name. Let's call it sensor dashboard. Just to differentiate from other dashboards, let's give it today's date. And here in these three dots, or rather over here in the under edit, not under three dots, under edit, you'll see add a tile. This is where we are going to make the different charts in the dashboard, which is real time. So the first chart we are going to make, let's say a card which shows the real time temperature and humidity. Now, in this case, we will take the real time streaming data. And when I select the real time streaming data, you will see the data sets that are available. Right? So this is the data set that is getting updated on real time. Select this data set. And we're making a card. So let's give the value of the card. The first card is of temperature. And you can already see the temperature coming over here. We can give the title, temperature, degree Celsius. And apply. And you have the temperature card over here. Very soon you will see that this temperature card is changing dynamically. Okay. Of course, here the latency is a little low. That's why we have not used edge platform. So the change will be a little slow than what typically will happen if you use edge computing. We'll add another tile in the meantime. The same data. And this time we are going to take the value of humidity. We have the temperature and the humidity. And it should be changing okay, soon as we go along, okay, because the data is constantly getting generated from the Raspberry Pi. We can see the data getting generated from the Raspberry Pi. There seems to be a little bit of a problem here. Yeah, so the Raspberry Pi stopped for a moment for some reason, but now it has started and you can see that real time the data is changing. Now, I can now draw a chart, let's say, line chart. This time I'll have a line chart and I will have a line chart where the time axis will be the window end and the value, let's say, is temperature. Similarly, I can have another one for humidity. need to ensure that it is running, because sometimes it stops. Need to ensure, yes, it's running. So you can see that this chart is dynamically changing. Okay. Now, this is where, the cloud computing doesn't have that much of latency. You can see some missing values. So it is not able to get all the data in time, and that's why some of the values are getting missed. However, when you use edge computing, this will be very, very smooth. Let us also make a humidity chart. Humidity. Here, come in yet. And as I said, that this is because we are using a cloud environment, not an edge environment. Hence, this many of the cases this will get dropped. Okay, but again, it will start getting the data. Okay. Let's also make a gauge chart. The gauge chart for temperature. The maximum, I'll allow the maximum and minimum value to be set automatically. Temperature gauge. You can see the minimum and maximum is here, and okay. And similarly, I can make a humidity gauge. Hence, humidity gauge. And some reason the humidity chart is not getting created. As I said, this is primarily because of the fact that this is a very high latency system and is not able to capture all the data in real time and render it into a chart. But you can see the cards are changing pretty fast, so are the gauges. Interesting thing is that Power BI has Gen AI based Q&A system where I can ask what is the maximum temperature. You tell me the maximum temperature so far has been this, okay, 31.99. What is the average temperature? You tell me the average temperature 26.60. What is the maximum humidity? You tell me the maximum humidity has been this 79.94. And what has been the average humidity? Tell me the average humidity is 71.12. Okay. Of course, these are all developing, so probably at this point of time, it will not be able to tell me how many times, let's say if I make a little difficult question, how many times the temperature has crossed 30. use the term exceeded, didn't take the term temperature more than 30. Okay, it takes that. It takes how many times the temperature is more than 30. It has taken all the timestamps where the temperature is more than 30. Okay, and this is a great feature where you can constantly monitor the temperature and check how many times it has crossed a particular threshold. So you can see how we were able to push the live streaming data into Power BI and make live charts in Power BI from the live data.